When the embryo is 1 week old, it has two layers of cells, a dorsal or outer epiblast layer and a ventral or inner hypoblast layer. During week 3 of development, the embryo undergoes gastrulation, where the cells in the epiblast layer differentiate ectoderm, mesoderm, and endoderm layers. These three germ layers are multipotent, meaning they can differentiate into any tissue or organ. By the end of gastrulation, we end up with a 3-layered trilaminar disc. So imagine the embryo like a birthday cake, with the ectoderm as the candles, the mesoderm as the green frosting, and the delicious strawberry cake as the endoderm. We can put 3 candles on this cake to help you remember that gastrulation happens during week 3. During gastrulation, some mesoderm cells start to differentiate and they form a structure down the back of the embryo called the notochord. And the notochord is a plate of cartilage that's a precursor to cartilage at the center of the inner vertebral disc, called the nucleus pulposus. The notochord starts a process called neurulation, where it stimulates the cells in the ectoderm layer, causing it to thicken, forming the neural plate. The neural plate starts to fold and it dips down, forming a neural groove with edges that are called neural folds. As the groove continues to grow ventral to the ectoderm layer, the neural folds come together and they pinch off from the surface of the ectoderm layer, forming the neural tube. The neural tube now sits between the mesoderm and the ectoderm. On the dorsal side of the neural tube, where the neural folds fuse, there are special cells called neural crest cells that migrate out and forms a new layer of cells between the ectoderm and the neural tube. Neural crest cells are like little explorers, and they migrate throughout the developing fetus to form a variety of tissues, including the peripheral nervous system, melanocytes in the skin, part of the facial bones, chromaffin cells of the adrenal glands, and parafollicular C cells in the thyroid. In fact, neural crest cells are responsible for so many of the body's organs and tissues that you might think of them as the body's unofficial 4th germ layer. At this point, like any hollow tube, the neural tube still has openings at both ends. A large opening at the top called the cranial neuropore, and a smaller opening at the bottom end called the caudal neuropore. The cranial neuropore seals up around day 25, while the caudal neuropore seals up a few days later, around day 28. Once the cranial and caudal neuropores have closed, the neural tube is formed. Meanwhile, ectoderm, or surface ectoderm, now that the neural tube is closed, starts to form the ears and the eyes. 2 bumps, called the otic placode and the lens placode, form near the cranial end of the ectoderm. Over time, the otic placodes will form otic vesicles, and they develop into the cochlea and inner ear. At the same time, the lens placodes develop into the lens and cornea of the eyes. Finally, a lot of the ectoderm cells go on to form sensory epitheliums like those in the nose and mouth. Others will go on to form the epidermis layer of the fetal skin, as well as structures associated with the skin like hair, nails, sweat glands, and mammary glands. Alright, as a quick recap, the ectoderm is the dorsal-most germ layer, and through a process called neurulation forms the neural tube. From the neural tube, neural crest cells migrate to help form the central nervous system, the peripheral nervous system, the sensory epithelium of the ear, nose, eye, and mouth, as well as glands like the sweat glands, mammary glands, and the pituitary gland. Here's a little story to help you remember the important structures derived from the ectoderm. So first off, you've got your germ layer cake, and then a guy that has no resemblance to anyone that made this video touches the ectoderm candle on the strawberry cake. His skin, which can help you remember epidermis, and nails get burned and turn black, which can help you remember melanocytes. And then he feels a sharp pain for the central and peripheral nervous systems, and he pulls his finger back. But in the process, he pokes himself in the face and sets his head on fire. His eyes, ears, nose, hair, and even teeth get set on fire. In a last-ditch effort to put the fire out, his body starts sweating and lactating to help you remember both the sweat and mammary glands, and even tearing up to help you remember the pituitary gland. Alright, that last one's a bit of a stretch.